Okay, let's dive right in. We have this idea that data is supposed to be clean, perfect, and just objectively true. But the bad data handbook kind of flips that on its head. It shows us that the real world of data is actually messy, it's complex, and honestly, that's where all the interesting stuff is. So today, think of us as data detectives. We're going to go on a mission to uncover the stories that are hiding right inside what most people would call imperfect data. So, the very first clue in our investigation is to challenge what we even mean by bad data. Because it's not just about, typos or a few missing values here and there. Sometimes the absolute best insights, the real gold, comes from the data that just doesn't behave itself, the stuff that shatters our expectations and forces us to lean in and really look closer. And this is the crucial part right here. When your data just refuses to cooperate with your model, it's not failing you. No, it's actually shouting a clue at you. It's trying to tell you that maybe one of your assumptions is flawed, or that there's a deeper truth you just haven't seen yet. So that failure, that's not a dead end. That's the first step toward a real discovery.
All right, let's start unmasking some of the usual suspects when it comes to bad data. But I'll give you a heads up. They're not always what you'd expect. Sometimes the data that looks the most perfect, the most pristine, is actually the most misleading.
Okay, take a look at this. It's a spreadsheet from an education report out of New Zealand. Every single number you see here is 100% correct. On the surface, it looks flawless. And yet, if you tried to feed this into a computer program for some analysis, it would be almost completely useless. So what gives? Why is that?
Well, here's the problem. This data was built for human eyeballs, not for machine logic. Our brains are amazing. We can instantly see the patterns, the context in those merged cells, and the visual groupings. But a computer, it just sees a confusing jumble of cells. It has no idea what to do with it because there's no simple, repetitive structure for it to latch onto.
So, the layout on the left, that's what we just saw. Super intuitive for us humans. But the tidy format on the right, that's what a machine needs to work its magic. It's a simple rule. One observation per row, and each variable gets its own column. It seems like a small change, but this is literally the key that unlocks the power of automated analysis, letting you crunch millions of records in a blink. All right, here's another culprit that's hiding in plain sight, and this one can silently sabotage so much of your work. It's text encoding. Now, to you and me, these two names look pretty much identical, right? Jose, same guy. But to a computer, whoa, they can be as different as apple and orange. And that makes it totally impossible to match records if they're coming from different systems. And why is that? Well, it's because different computer systems use different secret codes, what we call encodings, to represent characters. That little accent mark or a symbol like the euro sign, it can be represented by totally different numbers depending on the system that created the file. So if your program tries to read that file using the wrong secret decoder ring, your entire analysis can just fail. Silently. No error message, no warning, nothing. So how in the world are we supposed to find these hidden clues, right? I mean, you can't just stare at millions of rows of data and hope to spot something. Well, this is where we open up the Data Detectives Toolkit. Okay, and our first tool is, it's going to sound almost too simple, but it is incredibly powerful. Just make a chart, specifically a histogram. Seriously, don't underestimate this. Just visualizing the shape of your data is very often the fastest way to spot something weird going on. So, imagine this scenario. Someone hands you a massive file. It's got 7.5 million keyword prices in it. You open it up and all you see is a sea of numbers, just pure chaos. How on earth could you even begin to make sense of something like that? But then you take all those prices and you plot a quick histogram and boom. All of a sudden, a structure just emerges from the noise. That is the power of a simple visualization. It takes absolute chaos and turns it into a clear picture that's starting to tell a story. Just look at that. What is going on with that giant spike right at the 5-cent mark? Now, is that an error? Nope, it's a clue. It might be a default bid price, maybe a system minimum, or maybe it's a super common advertising strategy. We don't know the answer yet. But the key thing is that histogram just gave us a huge lead to go investigate. All right, let's move on to our next case. This one's a little different. It's all about taming complexity, not by cleaning the data itself, but by changing how we look at it.
Okay, at first glance, this database model seems totally logical, right? It's for tracking company costs, you've got your assets, your services, your departments, everything's in a nice, neat table. It all makes sense. The problem is, when you actually try to get answers out of this structure, you create what's called a combinatorial explosion. Basically, you create this huge, tangled mess of code, an accidental wave of complexity that the model itself is causing.
But what if we just change our perspective? What if, instead of seeing rigid tables, we look at what the data really represents, which is a network of relationships? Suddenly, on the right, the model becomes so much simpler. You can just see the flow. An asset connects to a service, which connects to a product. It's way more intuitive and reflects the real world better. And the lesson here is so powerful. Don't try to force every single problem into the one box you're comfortable with. Relational databases are awesome for some things, for sure. But for other problems, a graph database, or heck, even just a simple text file might be a much better fit. Using the right tool for the job can take a problem that seems impossible and make it, well, almost trivial. Okay, finally, let's talk about what might be the most crucial and honestly the most overlooked part of any data system. And that's the people. Because building trust with the humans who use your data is every bit as important as getting the data itself right. So how do you actually build that trust? Well, the book talks about data traceability, and it boils down to creating a really clear audit trail. It's basically 3 steps. First, you snapshot the original data. Keep an exact copy. That way you can always go back to the source. Second, you tag every single piece of data with where it came from. And third, you design your system so that if you find a bad source, you can easily pull it out and rerun your analysis. It's all about that transparency. And all of this really gets to the core philosophy of being a good data detective. You have to embrace this idea. In the real world, data is never going to be perfect. The goal isn't to chase some impossible, flawless ideal. Nope. The goal is to understand the imperfections, and then use that understanding to make practical, smart, informed progress. So the next time you look at a chart or a spreadsheet or you hear a statistic, don't just see the numbers on the page. I want you to see it like a crime scene that's full of clues. Look for those imperfections, question the assumptions behind it, and ask yourself that one crucial question. What story is this data really trying to tell me?